Alrighty, so let's have a look at an example of applying some bearings. And this example is going to involve some trigonometry because this is the unit we're doing, okay? And so we'll be applying some form of trigonometry to this problem. So we have a ship travels south for 5 kilometers, and then on a bearing of 120 degrees for 11 kilometers, okay? So first things first is you should always be drawing a picture of this situation, okay? So before I even look at the question, I'm just going to draw a picture of what's happening, okay? So I've been told that the ship travels south for 5 kilometers, okay? So my picture is going to start off by looking like this. And in fact, I'm actually going to try and make it to scale as much as I can. No, I'm not going to bother actually. 5 kilometers south, okay? So it started at some point up here, and it's traveled south, okay, in this direction for 5 kilometers. Then it's traveled on a bearing from 120 degrees for 11 kilometers, okay? So what that essentially means is if we were facing north, so once we got to that point, okay, where we stop, so I'll zoom in. Once we get to this point here, okay, if we were looking up north and we were then to turn and face 120 degrees, we would then travel down. And so it would look something like, probably something like this, okay? And we know it's going to be a bit longer because it's 11 kilometers. In fact, I'm going to go over it in red to match the rest of my diagram, okay? And so we know that this is 11 kilometers. So what's he done in total? Well, okay, so what he's done is he's gone down this path here for 5 kilometers, then he's turned 120 degrees from the northern shore, so he's, he wouldn't have, turned north and then gone 120 degrees. He would have just turned his boat till he got the bearing of 120 degrees, and then he's traveled in this direction here, okay? Like that. So that's our picture, and that's what we've got, okay? Our first part is find how far east the ship is from its starting point, okay? So how far east? Not how far southeast, not how far south, how far east. That is, if we were just to look on an eastern scale, so from our starting point, how far east, so how far directly east, has he traveled, okay? So in other words, I'm looking for how far from here to here has he traveled, okay? So you can see my picture, or my little scale above, okay, my picture, and I'm essentially looking for how far he's traveled to the right, okay? Well, if I bring this scale down, I'm essentially looking at, well, how far has he traveled in this direction, yeah? Because when he does his first 5 kilometer trip, he doesn't travel east at all. He only travels east when he does the 11 kilometer part of his journey, okay? Now, you're probably asking, well, why does it actually matter whereabouts we draw this line, okay? Well, the reason why I care about drawing this line here is because I can then put another line coming down like this, and lo and behold, we have a right angled triangle. And now, being in the trigonometric topic, we can actually solve this problem like a trig problem, okay? So, what do we need to solve a trigonometric problem? Well, we need two sides and an angle. Now, we've already got one side. We've got this hypotenuse that's down here, because we've got the 11 kilometers that's down here, okay? We want to know how far east he's traveled. So, in other words, we want to know how far along this direction he's gone. So let's call that value x along there. We don't care about how far south he's gone, not yet anyway. So we're going to ignore that for now. But now we also need an angle, okay? Well, thankfully we know what angle he's traveled, and we know what angle he's traveled from north. The angle that we know, and we drew it in before, is we know this angle coming around like that, okay? Now, obviously, this angle is too big because the angle starts outside the right angle triangle. But we do know that this bit out here is equal to 90 degrees because if this point up here is directly north and this side here is directly east, then he must have traveled, well, that part in there must be equal to 90 degrees because there's 90 degrees between north and east. So, how much does that leave us with left over in this corner here? Well, we were told that he travels 120 degrees once he gets to that point. So if this first bit up here is the 90 degrees, okay, so he's done the 90 degrees there, then this extra bit must add up to 120 degrees. So 90 degrees plus what makes 120 degrees? Well, in this particular case, it's going to be 30 degrees. And that's the angle that we're going to be using. We're going to be using 30 degrees. Okay. So on the side here, we're looking for, so part A said, find how east the ship is. So we're looking for this x value here. So let's find out what this x value is by using trigonometry. And what I'm going to do is I'm just going to quickly move this little picture over to the left so I have a bit more space to work with. Okay, so using the trigonometric ratio. Now, because we're doing trig, up the top of my page, I'm going to write in SOHCAHTOA because it's going to help me help me work out what ratio I'm going to use. Okay, so which ratio I'm going to use? Okay, well, I've got a hypotenuse in my right angle triangle. I've also got an adjacent in my hypotenuse because I'm using the 30 degrees as my starting point, or my angle, my little angular position. So, opposite is 11, adjacent is 30. We're using cosine. So, cosine of theta is equal to adjacent on hypotenuse, like that. So write the formula in first. Now let's substitute the points in, or not points, let's substitute the values in. So our angle is 30 degrees. That's our angle in here, in your triangle. Our adjacent, well, we don't know what our adjacent is, but we've got a pronumeral representing that unknown, which we've called x. And our hypotenuse in this case is 11. So cos 30 is equal to x on 11. All right, now to get the x by itself, solve it like an equation. To remove the 11 from the right-hand side, we're going to multiply both sides by 11. So it becomes 11 cos 30 is equal to x. Or another way to think about it is, we're just moving this 11 up to this side here. Now, once we've done that, we're just going to put it into our calculator, and we're going to get an answer. So 11 cos 30, close it off, hit equals, and we get, I just need to reset my calculator because I was doing some extension stuff earlier. Let's try that again. 11 cos 30. Now my calculator gives me something weird, but your calculator will probably give you this. 9.526. And we'll do the 2 decimal places. So 9.53. So the boat has traveled, because we've got to answer the question, because it's asked us a question. So therefore, the boat has traveled 9.53 kilometers. Okay. All right, now part B. Let's go back up and have a look at part B. Now part B says find how far south the ship is from its starting point. So how far south? Well, let's have a look at the south journey. I'm going to use a different color for the south journey. So the south journey, well, he starts at this point here and he travels 5 kilometers south. So we've already got 5 kilometers that he's traveled. But then he's also travels this many kilometers south as well. So directly south, okay? So he travels that many kilometers directly south. We don't know what that is, so we're going to call this, let's say, y, okay? Because we're using an unknown. We're not going to call it x because we don't know if it's the same as the x value, but we're going to call it something else. So the amount that he's traveled in total for the southern direction is just 5 kilometers plus whatever y is. Now, let's work out what y is. So for part B, to work out y, we're going to use another trigonometric ratio. Okay, we've still got that hypotenuse. This time we've got an opposite. So looking back up here, which one uses the opposite and the hypotenuse? Well, that's the first one. That's the sine one. So it's going to be sine theta is equal to opposite on hypotenuse. All right, substituting in what we know. Substituting in what we know. We know that the angle is 30 degrees. We know that the opposite is, where is the opposite? It is, well, we actually don't know what the opposite is. We're going to leave that as y. But we do know that the hypotenuse is 11. Now, just like with our cosine one, okay, just like with the cosine one, what we're going to do is we're going to move this 11 up to the top. We're going to multiply both sides by 11 to get the y by itself. y is equal to 11 sine 30 degrees. Okay, put this into our calculator like this, and we get, well, 5.5. That's a nice one. So y is equal to 5.5. So therefore, the boat has travelled. So how far has it travelled south again? Well, it's not just 5.5, remember, because this distance down here was 5.5. But remember, we've got to take into consideration this extra 5 that he travelled over here. So the total he travelled was 5.5 plus 5. So 10.5. The boat travelled 10.5 kilometres, okay, south. And so that's an application of bearings.